Good morning, everyone. My name is Austin Desmond with Horizon Solutions, and I wanted to thank you for joining us for Getting Connected with IAB, hosted by myself and Eric Haff. We'll be getting started shortly. Just want to remind everybody, we do have a large audience registered today, so to avoid any background noises, all mics have been muted. If at any time you have any questions during the webinar, go to the bottom of your screen and submit your questions in the Q&A feature, and we'll get to those at the end of the presentation. This webinar will be recorded and distributed to everyone at the conclusion of the presentation. And with that said, let's get into the presentation.
Thank you very much, Austin. Hello, everybody. My name is Eric Haff. I'm the Industrial Networking and Automation Specialist for Horizon Solutions. Just want to say thank you again for joining us. I'm very excited to be finishing off our third part of our Integrated Architecture Builder series. This is Getting Connected with IAB. On the agenda today, first, I would like to cover some concepts and terminology that I'm going to be using when we get into the actual live demo. This may be a review for some of you on the call, but it also may be new to some of our participants. Once we're done going through this jargon, we're going to go ahead and get into the live demo where we are going to create a plant-wide architecture using IAB by defining zones, by adding devices, and then doing some cabling. After that, we're going to test our network utilization. The very first concept that I'd like to bring up is the converged plant-wide Ethernet model. This is a model created in conjunction with Cisco, Panduit, and Rockwell. And it was established and made so that you could easily implement and create a robust, secure industrial automation environment and get communication to your enterprise environment that already exists. This framework is broken into multiple levels and zones, and I'm going to take a moment and go through those. The very first level is level 0, and that is the process level. This is where your sensors, drives, and actuators will live, and all other I/O devices. We move up to level 1, which is our basic control level. This is where your PLCs and other control devices are going to live. Then we move into level 2, which is the area supervisory and control level. This is where your operator and engineering workstations, HMIs, thin clients, things of that nature are all going to be. It's important to note that levels 0, 1, and 2 all make up the cell area zone. And we're going to be seeing that and getting into that a little bit later. Level 3 is a part of the industrial zone, and it is the site manufacturing operations and control level. This is where your automation servers, like your factory talk application server and your RODC, remote only domain controller, is going to be. Layer 3.5 is a very important level. This is the industrial demilitarized zone. The industrial demilitarized zone is meant to separate the enterprise zone and the industrial zone. This is where your terminal access services and replication servers will live. And then levels 4 and 5 make up the enterprise zone. And we're not going to be discussing that too much today. I wanted to talk about some resiliency protocols that we're going to be seeing once we get into the live demo. There's two different types of resiliency topologies that we're going to talk about. One is a redundant star topology. The other is a ring topology. For your redundant star protocols, you're going to have Ether channel, flex links, and MSTP, which stands for multi-spanning tree protocol. Ether channel is when you take multiple links between two switches and you logically put them into one bundle or one Ether channel. This adds resiliency because if you have 5 1 gig links between two switches and you bundle them into a 5 gig ether channel, and let's say one of those links goes down, it will continue to function just at a 4 gig capacity. And it has a very fast convergence time, less than 200 milliseconds. Flex links are also a redundant star switch topology resiliency protocol where you would have 2 links between 2 switches. One of those links would be in the active role, and one of those links would be put into active standby, such that if the active link goes down, the active standby will be engaged, and it has an extremely fast convergence time of less than 100 milliseconds. Multi-spanning tree protocol is standard on all managed switches, essentially, in this day and age. It's more of a protection against switch loops, as if you were to put multiple switches into one of the redundant star topologies that we just talked about. You would create a switch loop, and the MSTP would block one of those ports. And if the one port was to go down, it would open up that other port. But it has a very, very high convergence time. It's actually a couple of seconds. So that's not going to be very good for an industrial environment. We also have ring topology. We have REP, or Resilient Ethernet Protocol. This is when you put a access layer switches into a ring, and you would assign a ring supervisor. Within that ring, one of the links will be put into a down state so that you do not have a switch loop. And if, as the supervisor monitors the network, if one of the links were to go down in the ring, it would open up that link that is in the down state to allow communication to persist. Has a very fast convergence time. And then we have device level ring, which is exactly how it sounds. It's when it is at the device level. It was actually created by, it's a ring topology at the device level. It was created by Rockwell and their embedded switch technology. And it has an extremely fast convergence time. VLAN, or a virtual local area network, is a layer 2 construct that limits broadcast domains and is usually tied to a specific subnet. Now, the important part about VLANs when it comes to industrial automation networking is the fact that it limits those broadcast domains. Within industrial controls, a lot of the traffic is broadcast traffic. And as you continue to add nodes to a local area network, as you continue to build out your network, you are going and add more and more devices, you are going to continue to add more and more broadcast traffic onto that network. If you are not careful and you are not monitoring and managing this broadcast traffic, as you grow, you will start to see intermittent devices dropping off of your network and connectivity issues, usually because all of the devices on that network are trying to communicate to all of the devices on that network. So it's very important to use VLANs to limit those broadcast domains. Finally, I want to talk about network address translation today. Network address translation is a protocol that allows communication between multiple subnets with the same IP address scheme. A lot of people in the networking world probably understand and know layer 3 NAT, or the routing protocol. But it's important to note that Rockwell has actually developed its own proprietary layer 2 NAT, which does utilize MAC addresses and has line speed communication within its Stratix switches. So it's a lot faster and a lot better to use than that layer 3 NAT, which is a little bit slower. And with that, we're going to move ahead and go to our polling question number 1.
Thank you, Eric. So today we're wondering, who's in charge of setting up and maintaining the network in your facility? Would that be IT, OT operations, the corporate engineering group, or do you not know? I'll give you guys a few moments to vote in here and try and get a good representation. Give you just a couple seconds more. It looks like there's still a couple folks who might not have voted. And there we go. It looks like the overwhelming majority of folks, the IT department takes care of their network, and there's a few other unknowns as well.
Yeah, that does make sense. And as we continue, a lot of the conversations that we have here at Horizon Solutions are about that IT OT convergence. I'm gonna go ahead and move into the live demo. Gonna open up IAB. We are already updated, so we're gonna go ahead and press no. All right, so the first thing we're gonna do is create a new project with a network. Go ahead and choose Ethernet IP. And in here, I do want to showcase that you can choose to do a standalone Ethernet IP network where you could choose to start with a DLR or a linear network or just a free-form, just open canvas where you're able to add devices and connect them as you wish. But for today, we're going to start with the CPWE layout wizard. Going to go ahead and select all of our zones. Alrighty, and from here, we get into the CPWE layout settings. I just want to go ahead and say that this menu that we're going through right now is actually a one and done menu. Once you hit finish, it is going to create our network. And so you want to make sure that everything in here is as you want it before you say finish. So the subnet that we're going to be using today is going to be a 10.0.0.0. With a /24 or 255.255.255.0 subnet mask. It's going to generate a IDMZ for us, and it's going to automatically assign that to VLAN 2. And it already chose a matching 10.0.2 IP address scheme for that VLAN. Usual common best practice is to have the IP address scheme match the VLAN, but they don't have to. It's going to automatically choose firewalls for us and some managed switches. The industrial zone was already assigned its own VLAN and IP address scheme. If we change the CIDR block notation of the subnet, it automatically changes to dotted decimal. We'll just go ahead and keep it as it is. It's going to automatically choose a couple of core switches for us. And actually, I'll go ahead and take a second here. And let's say that we did want to change one of the switches that were here. We can go ahead and say, help me select a switch. And it has already chosen one of our rack mount Stratix 5410 distribution layer switches. And if we needed to specify particular features of a switch, then we can just go ahead and choose those here, and it will limit the amount that we're allowed to choose, which is very nice if you're having a hard time going through the SKUs. One thing that I did actually not mention in the resiliency protocols, which I will take a second here, is the HSRP. This is a layer 3 protocol for firewalls and layer 3 distribution switches. Essentially, if you have a router, one will be 2 routers in a redundant fashion. One will be in the active, the other will be in a standby, such that if the active one goes down, the other one will be able to pick up all of your routing. All right, let's go ahead and keep the one that it specified for us already, though. VLAN 4, perfect. Let's go into the cell area zone here. This is where we're going to send in most of our time. Let's do flex links for redundancy, and if you just hover over these, actually, it gives you a nice little convergence time noting there. And again, if you had to and we wanted to change out this switch, we can go ahead and go in here and go through all of our switches, but we'll just keep the one that it has for right now. I'm just going to go ahead and add a switch here in our cell area zone. And everything looks good to me, so we're going to go ahead and say finish. From here, it's going to generate our architecture with all of the zones that we were describing. We have our enterprise zone, our IDMZ, or industrial demilitarized zone. We have our industrial zone, our level 3 operations. And then right here is our cell area zone, those levels 0, 1, and 2. This is where we're going to be working for a little while. All right, so let's add some devices to this. Let's say that we wanted to add a switch somewhere in this topology, but we didn't know which one that we wanted yet. So we would go ahead and use help me choose an Ethernet switch and drop it in there. And from here, you can choose if it's going to be an access layer switch, if it's going to be managed, unmanaged, and also pick which features it has and help you limit down and choose the right one for you. That's a good thing to know. The first thing we're going to do is we're going to add a linear topology to our cell area zone here. Going to do that by clicking, dragging that across. Now let's go ahead and add another one really quick. Say okay. Let's do this a little bit. All right, perfect. And let's go ahead and let's add some devices to this. And I'm going to show you why we chose to use this as opposed to using the connect tool and connecting everything up. That makes things a little bit easier in just a moment. But let's go ahead and add some. Let's add some panel views to this. So we're going to scroll down here. Refined. Operator interfaces. Terminal. Panel view +7. Performance. Let's do a 10-inch. Okay. So as we're adding this device, we can choose which switch we're going to want it to automatically connect to. Let's go ahead and go with switch 01. Let's go ahead and throw another one of those up in there. Perfect. Okay, let's zoom in a little bit. It's a little small. All right, now let's add a, let's go for a 1769 L36 ERM. All right, compact logics. Oh, perfect. Okay, and now let's go ahead and add some motion drives. Let's do some kinetics 350s. Let's add a couple of these on here. Let's do like 3 of them. 2, 3. Okay, so we have our motion linear network up here. Now, let me zoom in so I can see this a little better. We're going to go ahead and select the connector tool. And we are going to connect our linear network to our switch. And we are going to grab our compact logics. And let's reorganize our kinetics here. Then we'll go back to here. And because we use the connect tool and we are connecting to this linear topology, it automatically used the embedded switch technology of our compact logics. And it plugged one of the switch ports into the access layer switch and the other switch port directly into our motion network. Also, the Kinetics 350, when we put it onto the network, it automatically added these ETAPs, as you can see. And again, that's because it was on a linear network and we needed, this does not have, Kinetics 350 I chose particularly because it does not have dual port embedded switch technology, just to show that. Let's go ahead and throw some remote IO on here. 1734. Let's do a NCR. Perfect. And let's populate that really quickly. All right, let's put one of these in here. and OE to C. Okay. And finally, let's go ahead and add IB2. One more. All right, perfect. I'm going to go ahead and go out of our hardware view here. We're going to go back to our networking view. And from here, I'm going to want to duplicate this 3 times. And now this is just going to limit the amount of work I have to do in populating those over again. Awesome. All right, now let's go back to our connector tool. Connect this up really quick. Make it look nice. Okay. Now, a remote I/O, let's say, and this does have the embedded switch port technology, so it automatically added it, utilizing both the ports. But let's say that this remote I/O is very far away from each other. So we're gonna have to use some fiber. We're gonna have to go way above the 100 meters that copper cabling is going to be able to do. So for that, we're going to right click and we're going to go ahead and add some ETAPs that are going to be utilized as protocol converters. One, and then one more. Oops. Add an ETAP. Okay. And we said that there was going to be quite some distance in between here. So let's go ahead and make that change. Let's go into configure connection. And let's change this to our multi-mode fiber. We'll do a custom and let's do, I don't know, 200 meters, sure. We'll go ahead and do that a couple more times. Just multi-mode fiber, custom, 200 meters. And let's do that one more time. Let's go to fiber. Awesome. All right, and if we zoom in a little bit, we can see that the black, if you guys can, it's a little bit hard to see because it's gray versus black, but the black cabling is indicating that we have fiber runs between these, and the gray is still our regular copper. Let's go ahead and take a look at the cable information by going to SIP and cable info here. And we can now see that the standard 2-meter runs have been changed to the 200 meters to indicate what we're running fiber. But also on top of that, let's go ahead and get rid of this for 1 second. The ETAPs that we put onto this linear network, the part numbers have actually already been changed to accommodate the new fiber connectivity. So this connection for this remote I/O currently utilizes 2 copper and 1 fiber. So this has been changed to an ETAP 1F. This has been changed to a 1783 ETAP 2F to accommodate the 2 fiber connectors and the copper, and so on and so forth. So it's just a little bit of showing you what IAB is doing in the background to help you. All right, so now we have our we have a pretty nice little cell area zone laid out here. We've put some cabling in. Let's test some network utilization really quick. Actually, let's before I do that, let's go into switch number 1. And now this is the switch view. This is very nice. Shows you all of your ports. These are our fast Ethernets 1 through 8. And it shows our gigabit Ethernet connectivity down here. I'm going to change the cable length for this HMI device. It also shows you exactly what it's connected to. And 2 meters, that's not really going to be good. So let's go ahead and say that this is going to be let's say this is a 25 meter run. Just showing you another way of setting up the cabling. Let's do a 25 meter run here. All right, let's go back to our plant-wide view. All right, that looks a little bit better. And let's go and test. Let's see what our utilization looks like. Kind of hard to see with that there. Okay. So for our network that we built out, it looks like we're sitting at 49% utilization, 36 respectively. So that's pretty good. Yeah, well within the green. But we do have a couple of HMIs on our network, and we're going to want to make sure that we add HMI traffic. So let's link our HMIs to our PLCs, and let's add in some tags. All right, and say okay. And then go back in and check it once again. Okay, and so we have overutilized the communications port of our compact logics. That is not going to be a healthy network that we have set up here. And there's a couple ways that we could we'll just say yes to that. We can mitigate this. We could change our compact logics to a beefier processor or potentially a different type of processor. But let's go ahead and go back in and say, you know what? I accidentally added a 0 in there. It was really supposed to be 100 tags. Say okay. Check it again. And we are back well within our networking specs for the network that we have set up in all of our devices. Sure, save. All right, so that looks pretty good. So we have ourselves a nice little motion network with some point IO and some HMI traffic going on. Let's go ahead and zoom out here. Oh, I apologize. It's also important to note that as the structure was built out, all of the redundant protocols and links were already pre-built for you and added to our access layer switch. You can see that it automatically added the SFPs based off of the single or multi-mode and speed that it's going to be connecting. And that'll be added to your bill of material automatically. Let's go back over to the plant-wide view. Zoom out a little bit. Clean this up. Okay. Bear with me one moment. Just going to want to clean this up just a little bit. Let's put this up here. Move this. Try and move these down. Move this over here. Okay. All right, now let's go ahead and say that this is a cell. Let's expand our industrial zone, and let's go ahead and create another cell just like it. We're going to go ahead, right-click, and copy cell area 1 and all of its contents. We're just going to go ahead and paste that group. Do a little bit of cleanup here. All right. Let's go ahead and go to configure our new zone. We've now created cell area 2. It has created a new VLAN and applied a subnet and subnet mask, address and mask to that VLAN. Let's go ahead and change the color so we can see it a little better. Distinguish it from our other cell area zone. And it has automatically re-IP'd addressed everything inside of the cell. So as you can see on VLAN 6, this PLC is now 10068. Over in our cell area 1, we actually have VLAN 5, and we have 10058. Also, it already added in our redundant connections back to our distribution layer. And let's go ahead and just do that one more time. So let's copy it. Copy cell area zone, all its contents. Okay, do a little bit of cleanup. Make sure to grab everything here. As you can see, it created it, all the VLAN and subnet information already, and re-IP addressed everything. Let's make it a nice color. Okay. And so now we have 3 different cell area zones for our plant-wide architecture. Okay. So now let's say in industrial manufacturing, automation, networking, if you work at an end user facility and you get a new machine or you get a new line installed, unless you buy a piece of machinery from an OEM, unless you specify during the commissioning process with that OEM or with the system integrator who's going to be coming in and installing that and helping getting it up and running, like what IP address scheme you're going to use, you may end up with a local area network of a machine that's something generic, like a 192.168/24 network. But what happens when you try and take that piece of machinery and you try to apply it to your architecture as a whole, your enterprise architecture as a whole? Well, unfortunately, you might run into issues with duplicate IP addresses. It might cause routing issues because there might already be a route for that 192.168 existing within your network. And so we do have a way to get around this. Let's go ahead and add a new, let's go ahead and expand this out. We're going to create a new subzone. And in this subzone, we're going to allow network address translation. And it's going to be a 192.168.1. Let's go ahead and make this a little bit bigger. All right. And let's say that we were going to get another one of these. So let's go ahead and copy all selected and paste the group. Okay. Now it's giving us a little bit of an issue here. It's saying this NAT device is incorrectly connected. Topologies networked outside of the NAT subnet is connected to a LAN side non-NAT designated port. Well, let's go ahead and take a look at that. Sure enough, Fast Ethernet 1 is going to our access layer switch, but unfortunately, we only have NAT on the GI Gigabit Ethernet 1 and Gigabit Ethernet 2 ports. So let's go ahead and let's move this. Got to move it here first. And then you got to move it right here. We'll say yes. All right, now everybody's happy. We're going to be utilizing the functionality of this BMS10 CGN Strike 5700 switch with NAT. Let's go ahead and add another subzone. Utilizing NAT again. Okay. I actually do want to space those out a little bit. All right, and let's go ahead and copy everything here. And paste. All right. And we already had the correct switch port when we copied it from over here, so it was all set. And let's go ahead and take a look. We have this PLC is 192.168.1.8. And the new zone that we created, this PLC is also 192.168.1.8. But it's important to note that we won't have duplicate IP address issues because this managed switch, which is going to utilize a NAT table, is on VLAN 5, 10.0.5.23. And this managed switch, which is going to utilize a NAT table to propagate traffic to the 192 below it, is on 10.0.5.22. And therefore, we're showing that we can utilize NAT and multiple address subnets that have the same address scheme. As we zoom out a little bit, we have our, and it's hard to see because it's a little small, but we have our whole plant-wide architecture to lay it out. And you can continue to build it out using the tools that we've shown you. Alrighty, and with that, I'd like to go ahead and say that this has been recorded today. If for some reason, someone was unable to make it and you think that they would benefit from seeing this content, they can always go to horizonsolutions.com /resources webinars on demand webinars, where this is going to be posted either tomorrow or the next day. You can forward it over to them and hopefully they get a little bit out of it. And with that, we're going to move on to polling question number 2.
Thank you, Eric. Just wanted to ask everybody if you, after this presentation, think that IAB will be beneficial to you and your company for future network layout and design. Give just a few more seconds here for the final votes to come in. All right, it looks like pretty much everyone has voted. So we'll share these results. And it looks like most people think that this will be a helpful tool, which means, Eric, you have done your job and we've shown off the power of IAB pretty well, it looks like.
Yeah, thank you. Yeah, I'm hoping we can maybe sway those that can't tell yet, but at least no one said no. So, alrighty. And with that, I want to go ahead and move on to our Q&A section. Austin, did we get any questions during the presentation?
We did. So we had, the first question that came in is, in NAT, what do we mean by the same IP address scheme?
Okay. I'm hoping that by the end of the presentation, that would have potentially, I would have been able to show that. But essentially, let me zoom in a little bit here. We have our NAT zone 1, which was created with a, let's configure the zone. The IP address scheme or subnet was 192.168.1.0 with a /24 or a 255.255.255 subnet mask. This NAT zone 2 has the exact same subnet address scheme or 192.168.1.0 with a 255.255.255 or /24 subnet mask. And essentially, these will not have duplicate IP address issues because the switch, the managed switch that we're utilizing, is going to use network address translation so that the devices within this 192.168.1 will not communicate well to the, they won't communicate to the greater network as a whole on that IP address. And you use a NAT table, it's actually called, within the managed switch, where you would give a one-to-one NAT translation of this IP address to a new IP address that's most likely existing on the 10.05 subnet. So to everyone else out here, like this PLC, who's on 10.06, when he's trying to communicate to this PLC, he would actually see it as a 10.0.5.100 or something to that effect, whatever you made that NAT table. But really what we were doing was we were mitigating, or we're removing the issue that this subnet and this subnet are the exact same by utilizing the NAT table within our managed switch. And I hope that helps.
That was a great answer, Eric. On the same note, does IAB create the NAT table, or does that have to be done manually within the processor or within the configuration of the switch?
From what I can tell, we cannot create NAT tables yet within IAB, but yes, that NAT table is going to need to be created within the managed switch itself, either by using the web browser for the switch or using CLI, some form of connecting and consoling into that switch and using Cisco commands.
Excellent, thank you. We had another question come in as well about a specific switch, but I think this also applies to a little bit broader question. The specific question is, if I had a Juniper layer 3 switch in my cell zone, can that be added? I think to a larger audience, we may also want to know, can any layer 3 switches other than Rockwell's be utilized within IAB?
Yeah, that's a good question. So you're talking about like a Juniper like distribution probably, or a core layer switch. And if we go here and we want to change this switch, you can use a generic switch, it's called. It would be like a generic 48 or 24 port switch. But unfortunately, it pretty much the only part numbers that we can choose from within IAB are the Stratix switches, a couple of Cisco firewalls and Cisco switches, and then generic is the only other option that we have. So unfortunately, like HP or any other vendor that you might have distribution switches existing in your infrastructure already, we would just need to call those generic switches. But they should, within like a logical diagram that you're trying to create here, should still serve the purpose.
Excellent, thank you. And we had one final question come in. Are there any additional tools that can be used to help build out the existing networks into an IAB format?
That's a great question, and a good little plug that I can do for Factory Talk Network Manager. Factory Talk Network Manager is a piece of software that is, if you know something about SolarWinds solution, or maybe a Panduit Interview, it's another one of those solutions where it builds out, it goes out and scans your network, and it builds out kind of like a connection map of all the switches that are in your infrastructure. And from there, you could take that information, and unfortunately, I don't believe it has an automatic import into IAB, but you could, from at least that map that it generates for you, you could more easily be able to get into IAB and create a logical network, or potentially just utilize that map that it already generated for you.
Excellent, thank you. And it looks like we have one final question. Do we have the ability, once a network is created, to convert from linear to a ring topology?
Absolutely. One second. So let's go ahead, and that's a great point. So that's another great reason to utilize this, because you can go in and you can pretty much just go into the connector tool here, and you could put you can start with a blank thing, put a bunch of devices in here, and just use the connector tool to connect everything up and do home runs and things of that nature back to your switch. But a good thing about the linear network is not only does it automatically do some of the work for you and add in devices and change them as you change the different cable structures, is you can actually go in and you can convert right here. We can convert to a ring. So now, let's get rid of our SIP info so we can see it a little bit better. We have now converted linear 3 to ring 5. And this ring is also utilizing the device level ring ports of our managed switch as well. So the switch is taking part in the ring. But let's go ahead and go back over to play one. And it automatically used your ETAPs and the embedded switch technology of our compact logics.
Excellent, thank you. We'll give it another moment to see if any more questions come in.
Yeah, there's some good ones. Some good ones. Looks like we got a couple more.
All right, it looks like those questions are more for just direct contact. So with those folks, we'll reach out to you and set up a time to continue the conversation. With that being said, I want to say thank you to Eric for putting this all together and remind everyone that this has been recorded and this will be distributed through an email from our marketing department by tomorrow sometime. With that, I believe we have concluded for today. Thank you very much for everyone who joined.
Yeah, thank you very much, everybody. Looking forward to working with all of you.